Paper 1, question 28. The diagram shows a sketch of the graph y equals cos x. So this thing here is y equals cos x. You don't need that bracket that I put in for now. That's a habit of mine, kind of setting the scene for when you've got more complicated trig stuff in A level or in advanced higher in Scotland, or higher in Scotland. So for me, that's kind of ingrained. I will always put a bracket around there regardless. I would suggest if you have aspirations for taking maths further that you get into this habit also. It just reminds you that what is in this bracket, that's the thing or that's the stuff that's getting caused or getting signed or getting tanned as far as the other ones go. But in any case, that is a graph of y equals cos x. Write down the coordinates of point A there. Now for GCSE and moving on, you need to know picture-wise in your head what a cos graph looks like and what a sine graph looks like. Now, the reason why I mentioned sine I'll get to in a minute. Your cos x starts up here, comes down and goes up in a waveform and would continue that way and will continue that way. Same with a sine graph, which I've got here. Sine graph is a wave as well. Sine and cos are technically the same looking waves, they just start at different points. So whereas cos starts at the top, sine starts in the middle, goes up and then down and then along and continues, okay? Both of them though have the same properties or the same sort of key points on the wave, like I said, because they're the same wave. Both can only go as high or as low as 1 and minus 1, and 0 is the middle, okay? That is the case for any sine wave and any cos wave. Also, the period of one wave, or in other words, the width of one wave, is always going to be 360 degrees. Okay? The middle of the wave then being 180, and these points here, these key points here, being the quarter moments of the wave, so 90 and 270. Same situation with sine here. I've got 90 there, 180 there, 270 there, 360 there, up to 1, down to minus 1. Those two graphs in general, you need to almost commit to memory, especially when it comes to moving on to doing questions like part B. So anyway, back to this. What is the coordinates of point A? Well, it's 90 along. It has no height. 90, comma, 0 is the answer to part A. Okay. For part 2, on the same diagram, draw a sketch of the graph of y equals 2 cos x. Now, the only difference between the first graph that you have there and the second graph, which I'll doodle here, y equals 2 times cos x, is the fact that you're multiplying it by 2. So in other words, it's twice as big, effectively. What is twice as big? The y coordinate is twice as big, because y is this thing, and now y is going to be 2 of this thing, so the y's are twice as high. In terms of what effect that has on the graph, it stretches it up and down. So the highs get higher and the lows get lower by a factor of 2, because that's what you're multiplying by. So in other words, every single point on that red curve now has a y coordinate that is twice as big. So 1 high is going to become 2 high, and 1 low, so in the case here, 1 low is going to become 2 low, or in other words, minus 2 high. Okay? And then similar at the end here, instead of going back to being 1 high, you're going to be back up here. The only things that aren't changed are the places where you have no height anyway, because when you multiply 0 by a number, you still get 0. Those 5 points I've highlighted there give you everything you need in order to be able to draw this graph that they want, because it still is a cos wave, it just looks taller, it just looks stretched. So you're still going to have this curving down like so through the point A, then continuing down to a low point here, back up through 270, 0, and ending up there. Now, I'm no artist, and that looks-ish like a sine wave, or sorry, looks-ish like a 2 cos x, as long as you have these key points identified. Alright, so you have those key points to begin with in a sine or cos wave that you need to know. The starting point, the middle point, the end point, these quarter points, how high is it at these? So sine wave is 0, then 1, then 0, then minus 1, then 0. Cos is just slightly out of sync. It starts 1 high, and then no high, then minus 1 high, then no high again, then 1 high. So when you change, in this case, they just multiplied it by 2, but you'll have other ways in which you can change the look of the graph. You can add numbers, take away numbers, you can multiply the inside of the cause, so in here, that has a different effect, which I won't go into because it's too much to talk about in one video. But yeah, if you know your key points, then whatever change goes on, be it to x or y, you can make the necessary adjustments. So in this case, y is going to be twice as big, all y's are twice as big, so these 5 points you know, just multiply the y's by 2 and you get the points you need to then draw the graph, which looks the same.